Hey everyone, and welcome to this explainer. Today, we're going to dive into a seriously fascinating piece of internet history and software engineering. We are going to demystify the real-time web. We'll be taking a look at exactly how the internet evolved to handle real-time data, and we're going to trace that journey from some incredibly clever early hacks all the way to modern purpose-built protocols. To kick things off and really ground this highly technical topic, I want you to think about an everyday problem we pretty much all experience. How does a chat app actually know when a new message arrives? Does your phone just magically sense it? Does the server forcefully push it to your screen? Well, the answer is a lot more complex and honestly a lot more interesting than you might think. All right, let's just dive right in. Here's the roadmap for our explainer today. First, the real-time web problem. Then, short polling, are we there? Third, enter Comet and long polling. Fourth, real-world polling examples. Fifth, WebSockets versus polling. And finally, number 6, choosing your real-time tool. So, starting off with section 1, the real-time web problem, built for waiting, not talking. You see, the original internet, it simply wasn't built for real-time communication. It was built on this very strict, stateless request-response model. It's kind of like a library. The client, which is your web browser, asks for a specific book, and the server hands it over. The server never just taps you on the shoulder to hand you a new book unprompted. If the server gets new information, it just has to sit there and wait until you specifically ask for it. This meant that developers who wanted to build things like live chats or real-time dashboards had to get incredibly clever to make it work. Moving on to section 2, short polling. Are we there? The brute force solution to real-time data. And this brilliantly illustrates the concept. Short polling is basically the network equivalent of a super impatient kid in the backseat of a car on a road trip, constantly asking, are we there yet? How about now? Are we there now? So under the hood, this operates as a really simple 3-step loop. Step 1, the client requests data. Step 2, the server immediately responds. If it has new data, it sends it right over. If it doesn't, it just sends an empty response saying, nope, nothing yet. Step 3, the client waits for a fixed interval, say maybe 5 seconds, and then just simply asks the exact same question again. It's this continuous, never-ending loop of asking and answering. Now, as you can probably guess, while short polling is super easy to set up, it creates some massive inefficiencies. Think about it. If a user leaves a dashboard open all night and absolutely no data changes, your client is still firing off thousands of requests, and your server is forced to process thousands of empty responses. It wastes network bandwidth, it dramatically increases server load, and because you're waiting for that fixed interval to pass before asking again, it's not even truly real-time. Which brings us to section 3, enter Comet and long polling, a clever evolutionary twist. Let's take a quick look at the historical lore of the early Wild West of the real-time web. You know, developers were trying literally everything. Back in 1996, they used Java applets embedded in Netscape 2.0 to force open raw TCP sockets. By 2000, we saw early open-source frameworks like Pushlets, using server-side Java to push events. But it wasn't actually until 2006 that software engineer Alex Russell officially coined an umbrella term for all these various long-held HTTP techniques. He called it Comet. Now, what's really interesting here is the origin of the name itself. Like, why Comet? Well, it was actually a software engineering joke. At the time, Ajax was the massive buzzword in web development, and in the US, Ajax and Comet were both popular competing brands of household bathroom cleaners. So the brand new tech term was quite literally just a clever pun on the cleaning aisle. So, out of this whole Comet era, the most popular technique to emerge was long polling. And if short polling is that impatient kid in the car, long polling is a much more mature analogy. It's a lot like going to a busy store, leaving your phone number at the front desk, and having them say, hey, don't keep asking us, we will call you the absolute second your order is ready. Mechanically, here is how that actually plays out. The client makes a request for new data, right? But this time, the server doesn't just reply right away with an empty nope. Instead, the server holds that HTTP request open, typically up to about 30 seconds. It just waits. If a new message arrives during that 30 seconds, the server immediately responds with it. The client processes the message, and then instantly fires off a brand new request to start the waiting process all over again. So the absolutely crucial point here is the direct difference in efficiency. Short polling just batters the server with repeated, mostly empty requests based on a dumb timer. Long polling asks once, and the server patiently holds the connection open until it actually has something valuable to say. This drastically reduces empty responses and gets you so much closer to true real-time communication. All right, section 4, real-world polling examples, how modern apps still use these techniques. Let's actually ground this theory in reality for a second. Have you ever submitted code on LeetCode? Their execution engine cleverly uses sequential short polling. When you hit run, your client submits the code and immediately gets a submission ID back. The client then repeatedly asks the server, hey, is the code for this specific ID finished yet? It keeps asking until it gets an accepted or rejected status. Because code compilation usually takes just a few seconds, short polling is actually a perfectly valid choice here. On the other hand, let's look at Dropbox and Telegram. The Dropbox API monitors your folders for file changes using long polling with a 30-second timeout. That way, it doesn't just crush their servers when you aren't uploading anything. The Telegram bot API does the exact same thing to fetch chat updates. Fun fact though, if you pass a 0-second timeout parameter to the Telegram API, it actually bypasses the hold and converts the request straight back into short polling. Next up, Section 5, WebSockets versus polling, scaling to the enterprise level. Enter WebSockets. Standardized under RFC 6455, they literally change the whole game. Unlike HTTP polling, which is always client-initiated and requires constantly opening and closing connections with heavy HTTP headers, a WebSocket opens a single, persistent TCP connection. And once it's open, it stays open. It allows full duplex bidirectional communication, meaning the server can push data to the client at any time and the client can push to the server, all over the exact same open channel. Let's move to a side-by-side comparison and see how this builds up. When looking at these protocols, a clear advantage emerges at scale. WebSockets offer true bidirectional communication, whereas long polling relies strictly on the client asking first. And because WebSockets use a single persistent connection, latency is incredibly low. Long polling has higher latency and higher server load because even though it waits 30 seconds, it still has to constantly drop and reestablish those heavy HTTP connections every single time a message is finally sent. And finally, Section 6, choosing your real-time tool. What should you use for your next project? First off, let's look at when to use polling, because seriously, do not just throw it away. You should absolutely use short polling for simple applications with predictable or infrequent updates, like our LeetCode example. Use long polling when you're building something like a chat app, but you know your users are behind strict corporate firewalls or proxy servers that actively block WebSocket traffic. Long polling is also an incredibly reliable choice when you are forced to integrate with older, legacy backend systems that simply can't support continuous connections. However, when performance is absolutely everything, you need WebSockets. Use WebSockets for highly interactive features like multiplayer gaming, live sports dashboards, or IoT telemetry streams. Use them for collaborative editing tools where multiple people are typing at the exact same time. Ultimately, for true high-frequency real-time applications running at a massive scale, WebSockets are the undisputed champion. We've journeyed all the way from the early days of a completely stateless web, through the clever hacks of short and long polling, right up to the modern elegance of WebSockets. So I want to leave you with this provocative thought to consider the next time you're looking at your own codebase. Look really closely at your network requests. Are your servers working too hard, or are they just waiting patiently? Thank you so much for joining me on this explainer, and keep building.